Welcome to a video entitled Understanding Databases. Now, for some of you, you may think, well, wait a minute, I've already got this. I see where you're going here, but let me just clarify something. I always, anytime I'm teaching like a live situation or a screencast like this, I always put this sort of information at the very front because understanding what databases really are and the main functionalities that affect everything we do with them, especially as administrators, really helps you put the various technologies of SQL Server together and understand why certain things are having to be dealt with or architected the way they are. So let's just go back to square one just for a moment together here and walk through this. Now, for those of you who are new to the database world, this is the foundational aspects that you need to understand to either administer a SQL database or to develop or design a SQL database. These things will affect every aspect of working with SQL Server in some aspect as you move through the various phases of working with the product. The term database refers to a collection of data. That's the simplest definition that you can find. Now, this data is somewhat related. It's easily accessed, it's managed, it's easily updated. Our idea with a database is to create a collection of related data that we can get to very easily, that we can manage it somehow, we can make sure that we keep it, we can back it up, we can make a copy of it, we can very easily update that data, we can retrieve data, we can do all kinds of cool things. The data needs to be retrieved in any order or using one of many or any kind of search filter that we can imagine. Now, normally we think of databases as being the computer-based databases that we work with these days. But to really understand some of the basic architectural and administrative challenges that we encounter with databases, let's back up a few years to understand why modern databases operate the way they do and why, as an administrator, you're going to bump into many of these issues. And you're also going to understand a little better why they present certain challenges that are going to affect their design, their operation, and their maintenance. Now, let's talk about a list that we would make for a camping trip. We need to take a tent, sleeping bags, water, large bug spray, flashlight, hammock, and a small bug spray. This camping list that we write on a piece of paper and put in our pocket is actually a database. It's very easily accessed. I just kind of pull it out of my pocket, unfold it, and I can read it. Then we can easily manage the list or the database just using a pencil. If we want to delete something, we just line it out. If we want to add something, we just write it in. And so if someone says, hey, what about this? We need to take something else. We just write it in at the bottom and we've made a new entry to our database. And then again, cross out items that we want to delete. Now, computer-based databases offer quite a few advantages over our paper-based database. The data can be much more efficiently and safely stored. By the way, nowadays we can access this data on almost any internet-based device that we can find. It doesn't even have to be internet-based. We can just simply put a copy of this database on all of our devices and access it. The data can be sorted in different orders very quickly and easily, and the data can be selectively retrieved. We can tell the database to only give us items that start with certain characters or have certain character strings within the various entries. We can do all sorts of cool things with them. Here's what really fundamentally starts to happen with databases that starts to create some challenges and opportunities for us as administrators, designers, developers, architects, all those things. Take your list that you created for the camping trip, and if I ask you if you have bug spray on the list, how do you find it? Now, we don't think about this, but this is actually what we're doing. We have to scan the entire list one item at a time. You've asked me, do I have bug spray? Well, first of all, tent, no, that's not a bug spray. Sleeping bags, that's not it. So I scan down that fourth item right there is bug spray large. Can I stop at that point? No, I cannot, because as you can see, there's another bug spray, a small version. You could have different types. You could have stuff that you spray, stuff that you light as a candle, all sorts of things. And so you're going to have to scan the entire list to find every instance of bug spray that's on your list. There could be duplicates or various types, just like you see in our list here. So it's going to be required that we scan the entire list. If we were to alphabetize the list, that makes reading the list much more efficient. because once I put it in alphabetical order, notice what just happened for this little answer to the question. I no longer need to scan the entire list to check for bug spray. Notice this list now. Bug spray is right at the top. I see bug spray, the first entry, bug spray, the second entry. And as soon as I see flashlight, this is inferring to me that I'm through with the bees. There's not going to be any other instance of bug spray in this list. And so I can stop reading at that point. From a database operational standpoint, this means we have to read less data off the disk. We have to do fewer input-output operations to retrieve this data. If you back up to when it was not in alphabetical order, the database actually has to pull that data into memory and read every list item in that database to determine how many instances of bug spray there were. When it's alphabetized, we can just do one IO. We grab 2 or 3 lines, we check, we got 2 bug sprays and a flashlight, we're done. Very efficient. So we alphabetize columns in our databases for this very reason. We do that by adding indexes to our tables. Now, alphabetizing made reading our database much, much faster and more efficient, but now it's kind of thrown a monkey wrench in there. It's a little technical term for you. It's made adding new items just a little bit more complicated, because notice what happens when someone says, oh, by the way, you need to be sure and take a shovel because, we've got to make sure we kill the campfire when we leave, make sure it's out. So you're thinking, okay, no problem. I'll just go add shovel to the list. Well, if our list wasn't alphabetized, we could add shovel really quickly and easily. We just add it to the bottom. But with an alphabetized list or an indexed database table, we can't just add it to the bottom. It has to go into the appropriate location. And so we've had to reorganize our index to put the shovel in the list. Before we put shovel in, this was our data. And then after we've added shovel, sleeping bags, tent, and water moved down. This is a minor thing here. In a paper-based world, we have to make another copy of the database or, do the little arrow thing or write it real small, and it starts to get tough to read. These issues are going to come back to you over and over and over with some of the required responsibilities you have as an administrator. Our paper-based version is easy to use now. But what if I had 6,000 items? Okay, we can't just read through it and look for duplicated items. We need some way to keep the data organized, protected from loss, and efficiently managed. And especially if we want to store more information than just the item name. What if we were storing the cost of these, the location, the weight, the color, those sorts of things? It starts to get much more complex. Now, in this course, we're going to deal with the various aspects of administering SQL Server databases. But over and over, you're going to see that a lot of what you have to do as an administrator is based on dealing with these very issues right here. We'll have to maintain indexes. We're going to have to worry about table structures and relationships and so forth. So all of these things are going to come back to you. Make sure this all makes sense to you, because you're going to hear and see this over and over and over. IOs, indexes, table relationships, they're all based on what you've just seen right here.